Good day everyone! My name is Samantha Nicole D. Fernandez. Today we're going to make an experiment called crystal lattices and unit cells, in which the objective of this experiment is that we'll be able to create the 3D models of the different crystal lattices and we'll be able to know the atoms and the coordination number of each unit cells. Of course, in order to make this experiment, we need to have the materials needed, which are the styrofoam balls, and the toothpicks. Our styrofoam balls will serve as a cell, while the toothpicks will serve as a lattice, or this is our basis, and a lattice, in order to make our crystal structures. Now that we have our materials, we will now able to start our experiment. Using our toothpicks and our styrofoam balls, we are assigned to create the 3D models of the following unit cells. First is the cubic crystals, which are the simple cubic, the face-centered cubic, and the body-centered cubic. Now let's start making our simple cubic structure. Now we have our simple cubic structure. Each corner of our simple cubic unit cell has a 1/8 of a whole atom. Since there are 8 of 1/8 atoms in our simple cubic, therefore 8 times 1/8 of these whole atoms, we now have one whole atom that can fit inside our unit cell simple cubic. And the coordination number of our simple cubic is 6. Now let's make our face-centered cubic. And now we have our face-centered cubic structure. Each corner of our face-centered cubic unit cell has a 1/8 of a whole atom. It also have 1/2 of a whole atom in each face of the cube. Since there are 8 of 1/8 atoms in our face-centered cubic and have 6 faces with a 1/2 of whole atom each, therefore 8 times 1/8 plus 6 times 1/2, we now have 4 whole atoms that can fit inside our unit cell face-centered cubic. And the coordination number of our face-centered cubic unit cell is 12. Now we make our body-centered cubic. Now we have our body-centered cubic. Same with the two cubic unit cells that we have encountered, each corner of our body-centered cubic unit cell has a 1/8 of a whole atom. It also has a 1 whole atom at the center. Since there are 8 of 1/8 atoms in our body-centered cubic and a 1 whole atom at the center, therefore 8 times 1/8 plus 1, we now have 2 whole atoms that can fit inside our unit cell body-centered cubic. The coordination number of our body-centered cubic unit cell is 8. Now that we're done making our cubic crystals, let's now make our hexagonal closed path. This is now our hexagonal closed pact. The 3 more cells in the bottle. Each corner of our hexagonal closed packed unit cell has a 1/6 of a whole atom. It also have 1/2 of a whole atom at the top and the bottom face of the structure with an additional 3 whole atoms inside. Since there are 12 of 1/6 atoms in our hexagonal closed pack, 2 faces with 1/2 of a whole atom and an additional 3 whole atoms, therefore, 12 times 1/6 plus 2 times 1/2 plus 3, we now have 6 whole atoms that can fit inside our unit cell hexagonal closed pack. And the coordination number of our hexagonal closed pack unit cell is 12. And those are the 3D models of the following unit cells. Once again, I'm Samantha Nicole D. Fernandez. Thanks for watching!